India Meteorology Department.
Your family, where you born?
New Delhi.
In Delhi. Your family is from Delhi. Okay.
Start now. Ladies and gentlemen, can I have a quick attention? Could you all please come forward a little bit? Everybody's scattered a little everywhere. It would be nice if you could come forward a little bit. I really appreciate your cooperation. Thank you. A warm welcome again to ICDRI 2023. The more often we repeat it, the more it becomes real. And it is. So the session today, this session is on improving infrastructure risk management, risk data for infrastructure planning and decision making. To give you a brief about the session focuses on understanding the importance of improving infrastructure planning and decision making with an attempt to deepen our understanding of the current challenges faced in utilizing the availability of data, ways to build on them, and improve its usability. It's my pleasure to introduce the moderator of the session, Mr. Mark Harvey, Head of Professions Infrastructure, FCDO. Mr. Mark Harvey is one of the 13 heads of profession at FCDO UK. He has worked for FCDO since it was formed in September 2020. DFID from its creation in 1997, and before that, the ODA from 1991. Mr. Harvey has worked on the UK's country development programs in India. He started with India, then Southern Africa, Nepal, Ethiopia, Afghanistan, and Vietnam, with occasional periods at the headquarters in London. Ladies and gentlemen, Mr. Harvey.
Thank you. Thank you. It's an absolute pleasure to be here. I was at the ICDRI in 2019 or 20, so 3 or 4 years ago, and it's come a long way. This is a fantastic event, just wonderful. My job is to introduce the panel and run you through the next 75 minutes. This is building on the previous session, which was looking at risk-informed governance, and in particular looking at that GIRI, the Global Infrastructure Resilience Index, and this one is going to move on to look at a little bit more about early warning systems and data. We've got a keynote speaker, Dr. Mahapatra. I'll introduce him in a bit more detail in a second. We have 5 panel members who are all joining remotely. So I don't know what I did, but they're not here. But we'll manage that, and we hope to have some Q&A with the audience as well, so we might have to resort to using pen and paper and feed up your questions as we go through. Anyway, also the session will be supported with slides, and the session support team will run through that. But I'll kick off with introducing Dr. Mohapatra. For all the panel members, I've kept the introductions quite short, because if I gave you all the details, it would take up the full 75 minutes. But Dr. Mrityunjay Mohapatra is the Director General of Meteorology at the Indian Meteorological Department, and he is the permanent representative of India with the World Meteorological Organization and a member of the Executive Council of the WMO. He's made significant contributions in the improvement of early warning services of the IMD, and he's popularly known as the Cyclone Man of India. Can I call you that? Okay. He hasn't objected, so Mr. Cyclone is here. Is it my slide next in the sort of introduction? I think there should be. Okay, I'll move on. Right. I just wanted to say one thing, is that I was asked to moderate this session, and I had to ask myself, what gives me any legitimacy to do that? But I know that disasters affect us all in different ways. And I reflected on this event. In my childhood, when I was about 8 years old, this took place in South Wales in the UK. It was the collapse of a tailings dam, a coal mine waste collection place, and it gave way. The groundwater came through the springs in the hillside, and it liquefacted the slurry, and the waste came down on a school and killed about 100 kids. Now, my mother was a teacher in South Wales at the time. We weren't directly affected, but I can remember it as an 8-year-old. And 15 years later, when I was a qualified engineer, I found myself working on tailings dams in Africa. So the incident for me, there's a couple of newspaper headlines there, poses the question, who knew about the risks? Were they identified? And based on what data? And was that data shared? Were the risks identified? Who knew? Who was informed? And most importantly, who was accountable? So the question is one of governance. So we have a huge responsibility in this field of disaster resilient infrastructure. I will introduce the other panelists when we get to them. We will go now on to the keynote speaker. I think we'll do it in that order. Okay, thank you. Dr. Mahapatra.
I will go there. Okay. So, namaskar, good afternoon and good morning to all of you. Esteemed moderator, and Dr. Mark Harvey, distinguished guests and delegates present in this conference, and also joining online, distinguished panelists for this discussion of today. I feel privileged to be associated with this discussion, and I'll try to put forth a few salient aspects of disaster risk reductions with respect to the infrastructure. So can I have the slides, please?
Slides are there.
Okay.
Can people hear? Okay.
I have to speak here, I think, better. So, fine. I think now I am audible. And once again, I convey my greetings. Good afternoon, namaskar, and good morning to all of you. Dear Dr. Mark Harvey, moderator of this discussion, distinguished delegates and guests present here and joining online, and my dear distinguished panelists of this discussion forum. At the outset, I congratulate CDRI for organizing this very important forum to check out the plans based on the status, progress, and the gap areas with respect to disaster resilient infrastructure. So I will be speaking about certain aspects in general and some specific aspects taken off in India with respect to the disaster resilient infrastructure and risk data needed for that purpose. Next slide, please. So if you just look at in a holistic manner the disaster risk reduction in any country, it basically deals with the actions and plans during disaster, pre-disaster, and also the post-disasters. While mainly the activity starts with the early warning, now it is the multi-hazard early warning system, which plays a key role in all the aspects and all phases of the disaster risk reductions, be it during disaster or be it the mitigation, prevention, and risk reduction processes. Apart from various structural measures, there are also many non-structural measures like the national policy, national act, or national plans, guidelines, and institutional mechanism. Considering India as a country for disaster risk reduction, as all of us know that we have made a quantum jump in recent years, in recent decade, you can say, when we have addressed all aspects, including multi-hazard early warning and pre, during, and post-disaster actions, as well as the response and recoveries. You will find that multi-hazard early warning system, which is a dominant playing role, during this management or disaster risk reduction, it has also improved significantly in the recent time. It is also needless to mention that the disaster risk reduction not only minimizes the loss of lives, but also it minimizes loss of property, and also it helps in managing the natural resources. In terms of forecast accuracy, if you just look at, there has been significant improvement in forecast accuracy by many countries in the world in the recent years with the intervention of science and technology. With respect to India and South Asia, if you just specifically see, there has been 40% improvement in recent 5 years compared to previous 5 years. And therefore, there are certain disasters like tropical cyclones and heavy rainfall, heat waves, you will find that loss of lives has been drastically reduced, which has drawn the attention of the international community. It has been possible to do so because of a collaborative mechanism, because of a cohesive mechanism in place with all the national policy guidelines, plans, and roadmaps in place in the national scenario. Next, please. So if you just look at the output is the excellence in early warning systems and excellence in DRR in India. You will find that, as I was telling, that 40% improvement in early warning system, and there has been pinpointed forecast accuracy for the tropical cyclones. There has been introduction of lightning warning in the country. There has been heavy rainfall warning, reducing the death. I will take this example of Kedarnath episode in 2013 and similar episode in 2021. While there was 4,500 deaths in 2013, it is only 30 deaths in 2021. So what is happening actually, because of the improvement of multi-hazard early warning systems and the institutional mechanism in place, the response actions has improved and therefore reduction in loss of lives. But the real challenge is that though the reduction has been visible in terms of loss of lives, the loss of property go on increasing, and therefore there is a need for disaster resilient infrastructure. The development in the country has helped other countries in this region. You can find out that there is no such cyclone which has caused death of more than 100 in any country in the Bay of Bengal or Arabian Sea region. Next, please. So if you just look at the need for resilient infrastructure coming together to minimize the loss of property, what you find that at first we have to identify the infrastructure, especially the critical infrastructure. This critical infrastructure may vary from place to place, may vary from country to country based on the need assessment. So disaster risk knowledge is the second requirement, which should be based on the historical data. So you have to check, organize, and archive and retrieve the historical data, and risk knowledge can be derived from that. What I mean by risk knowledge is that we should have the hazard zonation, vulnerability analysis, and climatological risk assessment for various types of disasters affecting the country. It may be the tropical cyclone for the coastal countries or coastal states, or it may be lightning for something else, or there could be the heavy rainfall or cloudburst or landslides, etc. in the hill areas. So therefore, we have to go for each specific hazards, we should have a specific infrastructure zonation of the hazards, vulnerability, and the risk. The multi-hazard early warning system, as all of us know that under the slogan of early warning for all, only 55 countries have the early warning. We need early warning for each and every country, especially the least developing countries and the small island nations and poor developing countries. So for that purpose also we have to go for investing so that we should have a multi-hazard early warning system. It is not simply the early warning system, but the impact-based forecast and risk-based warning. At the same time, the preparedness measures, prevention and mitigation measures should be a dynamic process for intervention and improvement from time to time. We should also adapt the scenarios in view of the climate change and projected changes in climate. Already we know what is the effect with respect to climate change, and also we know what is going to happen by 2050. So when you plan for disaster resilient infrastructure, that has to be incorporated. And at the same time, while we move over the time, there is also changing scenario with respect to the population, with respect to the landform, with respect to industrial activity, with respect to various socio-economic activities. That has to be taken into consideration. Next, please. So when you consider the critical infrastructure in view of all these requirements, you will find that there are many. I have just noted down something like that. For example, the first and foremost critical infrastructure, if you just look at, are the disaster management agencies, disaster management establishments. So that should be such a way that should be exemplary, and they should survive all types of disasters, be it early warning agency or be it the prevention or mitigation agency. They should have the infrastructure in such a way that should be exemplary. That should not collapse during the early warning system or during the approach of a particular disaster. The second one is that water supply. The water is very important, so we should ensure that water supply system does not succumb to the pressure of the disaster. Then transport, agriculture, sustainable urban development because urban population is increasing, tourism because of the moving populations, petroleum, dams and reservoirs, defense, power energy, highways, power grids, and aviation sectors. Aviation, of course, is the most important transport sector for relief and rescue and rehabilitations. So next, please. So if you just look at the non-structural measures, the most important non-structural measure is the regulations. We need a formulation of the regulation first. Many countries do not have regulations, many countries do not have the policy guidelines, and many countries also do not have legislative guidelines. So it is essential that we should have some kind of regulations, government regulations, and it could be in various forms. Just like some examples I've just put up, you can have the Bureau of Indian Standard Ports like India for buildings. You can have for coastal zone regulations, you can have hill area regulations, regulations for urban areas. We have all these things in certain countries, India has to a large extent. But at the same time also we should go for periodic review of the regulations. There should be specific regulation for each and every infrastructure. For example, if you have got a steel plant along the coast, this should have a specific regulation for that particular steel plant. That means with respect to disaster resilient infrastructure of that particular steel plant. If it is an airport on the coastal area, and it should have some kind of specific regulation what to do and what not to do at the approach of the tropical cyclones or the coastal flooding, etc. So specific regulation for each and every infrastructure is very much essential, especially the critical infrastructure. And standard operation procedure, guidelines, roadmap for each infrastructure and each type of multi-hazard scenario should be generated. Next, please. I'll just tell you to specifically what has happened with respect to early warning. So there is focus now. We should improve the disaster risk knowledge, then detection, forecasting, and improvement of early warning system, the preparedness and response mechanism, and warning dissemination. So these are the 4 components which have been taken up by early warning for all, for UN and WMO joint initiative. So during that, we have to percolate it to the regional level, then national level, then within the state to local level. So to carry out that, also we have to look into the current status, gap areas, and the plans. How can we meet it by 2025 or 2027? We planned it for 2025 in India, that each household should have the access to early warning at any time and anywhere in the country. But we are in a better place, but there are many countries we need the support, hand-holding. There are mechanisms established. How can we do it? That we should plan for. But I want to tell that we have got a seamless forecasting system. We have got impulsive forecasting early warning, which can help other countries as a demonstration. Next, please. So this is another example what we are doing with respect to tropical cyclones, resilient infrastructure. So what we have actually, we have got various types of climatological hazard analysis and forecast. We have got exposures. We have got the potential impact expected. So we have gone for a dynamic cyclone risk assessment mechanism. It has been established with the initiative of National Disaster Management Authority, India Meteorology Department, INCOIS, Hyderabad, and other MOS institutes, and also have taken into consideration the state agencies. It is now implemented. Each user at the level of the smallest geographical domain can access this wave-based risk atlas and take initial actions. So what happens actually, you can utilize it and you can assess expected losses, expected damages, and accordingly action can be taken based on the multi-hazard early warning system and hazard vulnerability and risk assessment. So by that way also we are planning for heavy rainfall and other disastrous weather events, and I hope this will bring a paradigm shift towards approach of the disaster resilient infrastructure. Next, please. So this is just an example of the tropical cyclone. This is cyclone Taukte which crossed Gujarat in 2021. You can just see that forecast was quite okay. Black line is the observed track and red line is the forecast track. Forecast will be provided 5 days ahead. Therefore, actions were taken by all the stakeholders along the west coast of India. we could provide information in the textual message. At the same time, graphical message could be generated with respect to the floods, winds, and surge hazards. And based on that, the loss could be estimated before the landfall of the cyclone. 3 days ahead, the estimation of the losses in terms of the quantity of the amount of agricultural field, number of industries, number of houses which will be likely to be affected, and again, amount of loss expected in terms of money, that is the loss forecast, also is being generated. That can help the disaster managers and policymakers to have a risk financing or risk forecasting. So this is the need of the hour, and India has made a beginning in this direction. Next, please. So what I want to say that there is need for measures creating disaster resilience infrastructure for each and every sector. I am not discussing here all the sectors. I will take an example of power sector here. In past 2 years, the Central Electricity Authority of India has roved in all the agencies, and they have brought out a disaster resilience infrastructure requirement for the power sector. I am just putting up from their report the salient features here. For strengthening of the existing infrastructure, there is a need something. They have told that modification of strengthening transmission line, reducing span in existing transmission lines, regular monitoring, patrolling, and maintenance of transmission lines, reconstruction of damaged infrastructure, anti-corrosive plant coating, conversion of air, insulated distribution systems, overhead distribution lines, and upgradation of foundation of poles, then splitting of large network into smaller systems, reducing the distribution lines. Next, please. Similarly, transmission line adaptations, also system planning cells, the critical infrastructure, mapping of TD infrastructure, designing of distribution network, emergency restoration systems, mobile substations, digitization of the system, distributed energy resources, use of unmanned aerial vehicles, standardization of use. Anyone interested, they can go through it. So what I feel that some kind of beginning has made in certain infrastructure area, and we have to do it for each and every infrastructure so as to minimize the losses and to have the resilient infrastructure. Next, please. Thank you.
Thank you, Dr. Mohapatra. I had one question which I've just had to rewrite for myself, thinking, could I just put one question to you before we go on to the panel, which is how do you accommodate ground truthing or triangulating with local knowledge from all your impressive data and warning systems? How do we get people to actually believe what comes from the official sort of systems? Thoughts on that? Oh, sorry to make you walk back over there. Okay.
Yeah, thank you very much, Dr. Mark. I just want to mention here what we do actually. Periodically, we went for a survey, feedback mechanism. We first survey was carried out in 2010, then 2015, then 2020. So based on this survey, what we found that 95% of the people believe the cyclone warning issued by India Meteorological Department. The second point was asked whether they act upon it. Yes, they act upon it, and there are certain states where even without any intervention, people evacuate from their own house and go to the shelters. At the same time, there has been unprecedented intervention by the government agencies, including central government and state government, to provide the cyclone shelters. Number of cyclone shelters, for example, it was just 23 in the state of Odisha when super cyclone came in 1999. Now it is more than 1,000. So that's why that is the intervention which has made possible to minimize the loss of lives. And to address the other question, what you told, what is the local intervention? What we do actually, we have got a 3-tier mechanism to address the requirement of the public. At the national level, we provide the information to all national agencies, including the Honorable Prime Minister's office and to the concerned chief ministers. At the state level, it goes to state chief ministers, concerned ministers, industries, etc., and all the stakeholders in the country. Then we go for the district level, it goes to districts, block development officers, tehsildars, and all concerned, those who are responsible for all the response sections in the particular district or particular area. So apart from that, what we have done actually, we have put up user-friendly products in 3 forms. One is the textual message, other is the JPEG image, the third one is the web GIS. All these informations are available in WebGIS so that any person, anywhere in the country can access it and find out his own area and find out what is the flood depth expected and what is the heavy rainfall expected and what is the wind expected in that area and storm surge expected. So apart from that, what we have done actually, we come for public weather service. We have the location specific informations. Also we have got the specific user informations. So for example, if I want to provide the information to the fisherman, it goes in local language, it goes in a text form, which does not need any TV or something like that. It can be passed out through All India Radio, and it is very simple. It is not provided with estimated central pressure of the cyclone. It is provided with only the wind speed, and it says how far is the cyclone from the particular coastal area, say for example from Madras, from Chennai, or from Tiruvananthapuram. It does not say latitude and longitude. But when the bulletin goes for fishery official, it provides the latitude, longitude, it provides little technical more. So similarly, if it goes to the ports, there is a need for estimated central pressure. It provides the information about the central pressure, information about other things also. We went for the supporting the coast guards and the Indian Navy, Ministry of Defense, and Air Force also. So for them, their requirement is addressed in the. So there are 13 types of bulletins every 3 hours issued to the specific users. And further, what we do actually, we have introduced the Common Alert Protocol. Through that Common Alert Protocol, the SMS messages are being sent to the concerned public with the public-private participation. I'll just give an example. 650 lakhs of SMS were issued in a particular cyclone which crossed a given coast. We also introduced the linguistic approach. That means the videos are generated in the local language, apart from English and Hindi, so that a common man can also understand the language and understand the informations and take action on its own. Thank you.
Okay, great, thank you. Comprehensive answer. So please do come and take a seat. We'll move on to our first panelist online, I hope connected. We're turning to Dr. Eleni, and I do apologize, probably won't pronounce your surname correctly, Marivili Lenio. You are the Global Chief Heat Officer to UN Habitat and the Arsht Rock Resilience Center. And you're working on building heat resilience in cities. You're also a member of the EU Mission Board for Adaptation at the European Commission and Athens Deputy Mayor for Urban Nature and Climate Resilience. So your focus is on urban heat. And I think we're going to hear from you about the challenge of designing and implementing green and blue infrastructure in local government. So I imagine you will have a lot of ideas about effective inter-agency coordination at the municipal level. So you'll offer your thoughts for participants. And if people in the audience who I can't see are writing down their questions on a piece of paper, do feed them up to me and we'll see if we can get a bit of Q&A going. Thanks. Over to you, Lenio. Thanks. Oh, something is muted. Try
Thank
again.
you, and thanks to Sid. Can you hear me now?
Yep.
Great. And distinguished guests, thanks for being here and for giving me the floor to talk a little bit about data and data-informed risk management from the point of view of cities. I would like to say here that unlike India, that is in the forefront of heat planning and strategic planning for heat, most of countries in the world do not have any plans for heat, strategic plans for building heat-related resilience, and that often because the phenomenon is exacerbated in cities are called to take measures and without actually having the type of data that they need, which are often at the national level and don't have the granularity that is needed for local decision makers, local leaders to create policies and make the right types of decisions. So for heat, the most important types of impacts that we have are on live bodies. Mostly we care about the humans, but also about the ecosystems that make our cities more livable and more healthy. So often part of the problem is that we do not have the type of data that we need that is health related. It's often difficult to, even for city leaders, to get data that are related to their region, to their territories from data that are related to morbidity and mortality. We find this in general in many cities around the world, that it's difficult to get this type of data. And it's important because we need to correlate them with climate data and geospatial data to find out where we need to support the infrastructures that will prevent deaths and that will make our most vulnerable populations safer. So the other side of data that is important, and this is kind of from the get-go, just to make the mayors and the decision makers more able to act, is economic related data. So how does heat affect productivity and generally the economic life of cities? So this is also something that is not very easy. Cities don't often have access to that kind of stuff. In Athens, we moved in three general categories for building heat resilience for the city. And the first category had to do with awareness raising, where we created a categorization of heat waves for Athens, specific for Athens, where we took climate data and correlated it to mortality data and created an algorithm that puts these things together, so we could actually communicate with people and with decision makers about risk specific for the city. And this, again, we managed to get mortality data, general mortality data for the city of Athens. But it, again, I know that for a lot of cities, especially in the global south, it's hard to have access to such data on city level, on the level of cities. The second general category of actions that we did for heat resilience was a preparedness set of actions, which are short-term actions directed to the most vulnerable populations. And there we needed geospatial data, we needed socioeconomic data, and we also needed infrastructure data. And that really is an important point, that, you know, there is somebody like a chief heat officer that can, as you said, work across departments in a city to bring all these different types of data together and the knowledge as much as possible, together with outside players like universities and research centers and national governmental agencies, in order to be able to start identifying where are the neighborhoods that are the most, and where are the populations, and where are the neighborhoods that are most at risk during heat, and how we can make sure that we have the right types of infrastructure, especially allocated to those areas, so that we can, again, save lives. And this includes health infrastructure, it includes energy infrastructure and water infrastructure, most of all, to make sure that, and this is not easy, as already mentioned, to have these types of data available on a granular level, and also to have the different departments. Final big kind of chunk of work that we do for, and probably the most important for building heat resilience, is falls under the redesigning cities, where we really have to bring nature and nature-based solutions and blue and green infrastructure much more intensely in the cities. And there we also need a whole series of different types of information that we don't have. We need to build capacity for designers and implementers to do these types of infrastructure, to have blue, green, or mixed infrastructure with gray, and to have the type of cost-benefit analysis in order to make decision makers decide to do these types of infrastructures, which are much more resilient and have many more ecosystemic services that can make our cities survive under the rising heat, which we know is increasingly an issue. And I'll just finish by saying that I always want to stress that part of the issue is a translation of data for and so that they make sense to decision makers and people that can make policies, create the right early warning systems, etc., so that they can then change people's behavior, so that then we can change lives. And I'll stop here, and I will leave the floor for my colleagues and take questions later. Thank you.
Thank you. Thank you, Lenio. You still appear to be talking. Oh no, sorry, that's the previous. That's a few seconds delay on that one. On that one, you're not. Okay, fine, thanks. Moving on, hold your questions. Do feed some up to the panel here, and I'll see if I can get them asked and hopefully answered. So from the cyclone man of India through to municipal infrastructure, we're now going to move on to hear from Dr. Srinivas Kumar, who is the director of INSOAS, which is the, I'm looking for it here, I've lost it. The Intergovernmental Ocean Commission's IOC of UNESCO and the Indian National Centre for Ocean Information Services. So you focus on operational oceanography and coastal multi-hazard early warning systems, and you've done work on multi-hazard vulnerability mapping. So looking forward to hearing from you, Dr. Srinivasa. And I have one burning question. If you're looking at coastal systems, why are you in Hyderabad? But move on. Go ahead with your slides and responding to those issues. Thanks.
All right. Thanks very much, Mark. And my co-panelists and then participants from far and wide, a very good morning, good afternoon, and good evening to all of you. I'm sorry I couldn't be there personally, but I'm glad that I'm able to join you online. And Mark, for your question on why we are in Hyderabad, we work on coastal issues, and then we are in Hyderabad because we are equidistant from both the east and west coast. Yeah. So I mean, so we actually have a lot of satellite reception that we do out of here. So most of our data we do using remote sensing, and they receive data from a lot of in-situ platforms. So we are located, almost in the middle of the country, which gives us coverage, all equally on the Bay of Bengal, Arabian Sea. So yeah, I'll start now with the presentation. If someone can bring up my slides. So yeah, I'll talk about the role of tsunami early warning systems for disaster resilient infrastructure. So I'll be talking about coastal infrastructure, and then what are the current arrangements, global or national arrangements with respect to tsunami early warning, and then how they can enhance our resilience to critical infrastructure in the coastal areas. Can we move on to the next slide, please? So most of the work on tsunamis was actually carried out after the 2004 Indian Ocean tsunami, which took about 230,000 lives, caused immense damage to coastal infrastructure, of course, and then caused a lot of damage in economic losses, about $14 billion US in economic losses. So after that event, India has actually started establishing a tsunami early warning system to mitigate future losses from such huge disasters. And then a lot of work started in the Indian Ocean region and also globally. So the Intergovernmental Oceanographic Commission of the UNESCO coordinated the establishment of regional systems, one in the Indian Ocean region. It's called the Indian Ocean Tsunami Warning and Mitigation System, one in the Caribbean, and then other in the Northeast Atlantic and the Mediterranean. These three systems added to the Pacific system that was already operational since 1965, which was the only system operational until 2004. And this was set up in response to the 1960 earthquake and tsunami in Chile. So there are now 4 regional systems. They operate as a global system of systems. And then what you're seeing in the middle top panel there is the coverage all these systems put together they offer to the coastal areas which are most vulnerable to the tsunamis in the entire globe. So if you see on the bottom panel, what you're seeing on the left is actually the different phases in tsunami early warning system, starting right from hazard and risk assessments to tsunami detection, warning and dissemination, to communication, of course, and then preparedness and response, which earlier speakers also alluded to. Now, each of those phases have very important things to offer to make infrastructure resilient. So I'll come to that in a bit. And on the right, what you're seeing, why do we need to have regional and global systems or a network system of systems? In this case is because most of the tsunamis are caused due to large earthquakes, at least 80% of them. And then the earthquake could happen somewhere, but then the tsunami waves it triggers can travel across the region or across the whole globe, depending upon how big the event is. So in that perspective, we need actually a collaboration and then systems that can actually work nationally, regionally, and globally. So the Indian system was set up in 2007. It operates out of INCOIS, and then it provides, along with Australia and Indonesia, provides warning to all the 25 Indian Ocean rim countries. Can we move to the next slide, please? Now I'll talk a bit about what are the individual components. So the tsunami warning systems comprise of seismic networks, sea level networks, tsunami buoys, and a lot of actually model scenarios, which can be used not only for warning, but also for advanced planning, actually, because you try to understand the hazard first. You need to make hazard maps, inundation maps, and then try to see how much of this inundation could impact, what will be the extent of the coastal area that could be impacted, and then what are the coastal communities within that, or what is the infrastructure within that. So that kind of hazard assessment is done. Then there are networks of sensors that can actually give information in real time, then the models that can tell you what is the expected impact. And then we work a lot with the communities, like Dr. Mahapatra was mentioning before, with the coastal communities to actually enhance the preparedness, and then so that they can act appropriately when a warning really goes out. And parallelly, there are also other multiple hazards that we manage, because this is just not one tsunami, because storm surges can actually cause coastal inundation. Long-term sea level rise can cause coastal inundation. So we need to look at it from a multi-hazard perspective. And then what we are trying to assess, or for somebody at the coast would be worried about any kind of inundation, irrespective of the source. So the panel, the map that you're seeing on the top right panel is actually a map that actually has projected coastal flooding due to tsunamis, cyclones, floods, sea level rise, and erosion. So we developed something called as a multi-hazard vulnerability map. We identified about 3,600 square kilometers of coastal area of the country that can be actually vulnerable to coastal inundation in the next 100 years in a climate change scenario. Now, these kind of maps are useful for really assessing the impact of such inundation on coastal infrastructure. You can actually using for planning. And the bottom panel, what you're seeing is actually a 3D GIS map, where again, we heard about why data is very important. Now, these inundation overlaid onto a 3D map of a particular coastal area, which we know is vulnerable to coastal inundation. Now, these maps are very important to actually build resilience to the infrastructure in the coastal areas, and be it buildings, be it ports, harbors, airports, and so on. Now, coming to how the early warning system works for critical infrastructure. Now, this is actually important. This focuses on ports, harbors, and coastal airports, and talks about specifically about tsunami warnings. And then in the Indian Ocean Rim countries, this comes out of results of a workshop, very important workshop held by the, organized by the IOC UNESCO, where we had operators of these infrastructure participate in the meeting and then assess the current status and what has to be done in the future to enhance the resilience of coastal infrastructure to coastal inundation due to tsunamis and other coastal hazards. Now, so far, the warning systems were focused on actually strengthening the upstream, because we, for example, we didn't have a tsunami warning system before 2004, except the Pacific system globally. But then we have a system. That means we have networks, we are able to identify events, we are able to send out information based on the scientific capability and possibilities, practicalities. There is information that is going out. And then there are also several preparedness programs that are being, taken up at the ground level to enhance the preparedness of communities. That is actually like tsunami preparedness programs. How do we actually make the communities more prepared and resilient? But then there is actually gaps on, specific infrastructure. So that is something that has been identified. That means whether the warning goes to, say, for example, a port and harbor, whether the ports and harbors have specific plans, disaster mitigation plans for making their operations much resilient or their infrastructure much resilient. So these kind of survey has been done and several gaps have been identified. So those are the things that are lifted. And you all remember the Japan 2011, the Japan tsunami, where actually we have seen how the earthquake triggered a tsunami, and then it triggered the Fukushima. We have seen the what happened to the Fukushima power plant. So it could be cascading effects. And then we have seen other examples where ports were disabled. The power plants were unable to be operated when disaster happens. So there is actually can we go to the next slide, please? And I spoke about this, and then the next slide. So that's my last slide. So which actually tells us what is that we need to do to make our infrastructure resilient. So one thing is actually for the existing critical infrastructure facilities to review their hazard and risk assessments, whether they are actually considering tsunamis or storm surges or coastal inundation within their planning and operations. And new critical infrastructure facilities should actually take up hazard and risk assessments in the design and development itself. And then one important thing is to develop standards and guidelines on the methodology for hazards and risk assessment. Like, for example, do we know potential sources of tsunamis? Is it a large earthquake happening at an X or Y location of 9 magnitude, or could something of 9.2 magnitude happen? Or could it just be 8 magnitude? What should we design for? So we need to actually have these credible sources, scientifically derived, and then we need to work out those methodologies, guidelines to develop that. And on the early warning and dissemination, some of the recommendations were that we need to have direct communication channels between the information generators and the receiving agencies of the critical infrastructure. And then we should have specific actionable guidance. Like, for example, we're also hearing before about impact-based warnings. A small tsunami might not impact a large vessel, but a very small, a strong coastal current can impact even a small boat. So those kind of impact-based things and then specific actionable guidance should be given to the coastal infrastructure agencies, operators, so that they can actually make their operations very resilient. And then the standard operational procedures at the emergency operation centers of these coastal critical infrastructure, that is something which is very important. And then something on preparedness and response, I'll end it now. So we need to have actually capacity building and training of all stakeholders. What are the data sets that are available? How can these data sets be used? How can we generate maps? How can we actually make ourselves operations and the infrastructure resilient? And this can be done through communications, drills, and so on. And the last thing is to enable high-level education advocacy by such fora like CDRI at the national and regional levels for enhancing the monitoring networks and development of guidelines for effective disaster risk reduction and collaboration between relevant national agencies and intergovernmental bodies. Thank you very much, Mark. I leave it there and hand the floor back to you.
Sulasa. I'm still looking at the audience to see who's got their hand up or they're coming up to the stage with a burning question that they've been preparing over the last few minutes. I'm looking, can't see anybody coming just yet, so we'll move on to Ben Webster from REAP. I'll introduce him. He's the head of the Secretariat of the Risk Informed Early Action Partnership. He's got experience, he's worked a lot in the humanitarian sector since 2003 within the Red Cross and the Red Crescent movement since 2012. And he works with them with the aim, with REAP, to make 1 billion people safer from disaster by 2025. So hugely ambitious, but hugely important. So Ben, I'll hand over to you. And I think in particular, we were going to look about trust between different stakeholders. And we touched on it when I asked Dr. Mohapatra about how you ground truth and get your community-based understanding of cyclones, and how you get that interaction between the high-level data and sort of technical knowledge and with what people actually understand on the ground. So Ben, can I hand over to you, and you'll have to guide the slides that you're using with the session supporters. Thanks.
Thanks, Mark, and good morning, good afternoon, good evening, everyone. It's great to be with you. I'm sorry I can't be there in person. I promise it was nothing you said, Mark. But yeah, an excellent panel and opportunity to explore further this issue around early warning systems and infrastructure. So as mentioned, the Risk Informed Early Action Partnership is actually a sister initiative of CDRI. So it was launched at the UN Climate Action Summit in 2019 with that ambitious aim of making 1 billion people safe from disaster. If you could pull up the slides, please, I'll explain a bit about the purpose of this partnership and how we are aiming to create trust between these different stakeholder groups. Because as Dr. Mohapatra mentioned, there's this whole value chain when it comes to systematic observations, and we'll hear more from Vincent, around the role of technology and satellites and so on, but how those support multi-hazard early warning systems, how we require finance in advance of hazards as well to support early action. You need the capability on the ground to be able to take action ahead of the hazards. You need really effective risk communication, not only the technology to reach people in remote locations, but also effective risk communication so people know what they need to do to be able to protect themselves, to save lives and their livelihoods and so on. So just to explain, next slide please. When REAP was launched, the convening partners, which spans governments, UN agencies, civil society actors, private sector as well, recognizing that we need to work across all of these different stakeholders, the climate community, the humanitarian community, the development community. Those convening partners agreed on these 4 high-level targets, which serve us as proxy indicators. Are we making progress to make 1 billion people safer from disaster? And target 1 is all around the legislation, the policies and the plans at a national level, which form a foundational basis for us to build on to be able to take early action to scale at the national level. I'll come on to this in a bit more detail, given that we're focused on risk governance today. But the second target is ensuring that the finances, both the financial instruments, but also the delivery mechanisms, are linked to effective early action plans on the ground. And there's been lots of progress within the humanitarian sector, making sure that humanitarian resources can trigger in advance of hazards, anticipatory humanitarian action. But that is really the tip of the iceberg. When you look at the resources that end up paying for disasters, the response and the recovery, we need to ensure that development banks are engaged in this discussion too, and that climate finance plays its role, that social protection mechanisms can trigger in advance of hazards as well. And there's a fantastic example in India where the MGN regs social protection mechanism can trigger based on climate data now. So that's been developed by Government of India with support from FCDO and IIED. So yeah, how can we ensure that financial instruments can link to effective early action plans in advance of hazards. And then our targets 3 and 4 really focus on the early warning systems themselves. Historically, we talk about the last mile. You know, there's this process of getting early warnings through and then trying to reach the last mile. Well, this partnership is saying that should actually be the very first consideration. You know, ensuring that people can take action should actually inform the design of the early warning systems themselves, and it shouldn't be a one-way linear process. It needs to be an ongoing two-way discussion, so that we are improving the early warning systems themselves and that people are empowered with the information to be able to take action. So those are the 4 framing targets of the partnership. And as you can see, we are aiming to convene the various different stakeholders across this full value chain to ensure that there are better linkages. So there are various ways that we try and create that space to ensure that different actors can understand each other and link up more effectively across governments and the international actors and the local actors. Last year, we recognized that language is a key blockage, you know, because we all work in our silos and use our own terminology. And it's actually very difficult to collaborate when you're maybe using very similar terms, but they mean completely different things for the finance community or the climate community or the humanitarians. And therefore, we developed a glossary of terms, which serves as a bit of a phrase book, if you like, to help these different communities understand each other better and communicate more effectively. So these are the kinds of initiatives we're aiming to take to strengthen the understanding, the trust between these different stakeholder groups, so that we really can scale up these approaches. But as I mentioned, I'll talk a bit more about Target 1. So next slide, please. We are we have a working group that's co-chaired by UNDRR, so Dr. Animesh Kumar from UNDRR's Bonn office, which brings together some of the international actors involved in supporting governments with comprehensive climate and disaster risk management. So we have UNDP and UNEP and WFP and FAO, but also IFRC, the NAP Global Network, the NDC Partnership, GNDR, which is a network of civil society actors active in this space. So together we mapped out that they're already working in 66 different countries. As Dr. Mohapatra mentioned, India has very significant experience and capacity in this regard, but there are many countries that aren't so advanced. And if you think about a small island state, you know, with a very small department that's responsible, has huge responsibility, a huge remit, how can we align our efforts, coordinate activities to make it as simple as possible for those countries to access the technical assistance they require, the resources they require to bring together the climate change adaptation policies and plans with the disaster risk management policies and plans, and take a much more holistic, comprehensive approach. We're talking about infrastructure today, but last week we were in discussions with the Coalition for Climate Resilient Food Systems. You know, health is another sector that's impacted, the environment. So all of these different sectoral approaches need to come together into more comprehensive policies, plans, and legal frameworks at the national level. So that is what our working group focused on risk governance is aiming to achieve. And yeah, there are many other ways that we're seeking to push this agenda forward, to get the different actors collaborating effectively together. But I'll leave it there and hopefully come back to questions and also hear from our fellow panelists now. So back to you, Mark. Thanks very much.
A little bit of a round of applause. Quite happy to take questions from panelists of the other panelists, because I'm still looking around the audience here to see people rushing up to the stage with the key questions. Yes, we've got one. Go ahead. You might need a microphone, or if you want to write it down. Ben, success. We have a question from the audience. It's made my afternoon. because I'm running out of questions. Go
Yeah,
ahead.
thanks very much.
Do you want to introduce yourself? And
Yeah, my name is Agathe Nougari and I work at CDRI Secretariat.
oh, that's cheating.
I know it's cheating, but I work in the Islands program of CDRI, and we have a lot of interest in early warning systems. And in the context of this work, we were wondering, and I think it's for, this question is for both speakers who just spoke about multi-hazard early warning systems. We would like to know if you have examples of early warning systems that provide alerts to infrastructure asset managers and not just general population. Because as CDRI, we are focused on infrastructure, not just how infrastructure works to deliver early warning, but also how early warning can be useful to infrastructure managers. So if you have some examples to share around this, thanks.
So, Ben or Dr. Srinivasa, do come back on that. Dr. Srinivasa first.
Yeah, okay, thanks for that question, actually. So, in fact, in the Indian context, I would say that actually all the, one of the main recipients of the warnings information that we generate is the critical infrastructure operators in the coastal areas. So that's a specific, group that we deliver warnings to. Like, for example, there are power plants in the coastal areas, or there are refineries in the coastal areas. So actually, we send our warnings. Whenever we have warnings, we send it to them. And then there are also occasions where we actually have meetings with them, try to work with them to actually build their stand operational procedures and then enhance their capacities to understand to the warnings that we provide, and then the kind of action they might need to, take for different kind of threat levels that we deliver. So nationally, we have such a mechanism. Even regionally, like for example, in the global system that I spoke about, which is actually managed by the Intergovernmental Oceanography Commission of the UNESCO. So there are actually efforts to develop specific services, like specific warnings to, for example, say the shipping. So the ships out at sea, actually. So how do they receive warnings from the regional service providers? Or, how the national service providers can provide, generate warnings to, the ports and harbors. So there are actually initiatives, even regionally and globally, trying to address specific stakeholders, actually, as far as tsunami warnings are concerned. So I hope that answers some of your question, but there might be others who might like to add, other panelists.
Yeah, please go ahead. Yes.
Okay. So I just want to add what Dr. Srinivas has responded with respect to tropical cyclones in India. We have the specific informations in the form of graphics and textual product for the infrastructures vulnerable to the tropical cyclones along the coastal areas. Just taking an example of the onshore and offshore industries, for each and every location, the location-specific impact expected and the necessary actions to be taken are suggested in the information product. Similarly, for the ports along the coast, a specific product is generated for each and every port in terms of the distance from the particular tropical cyclones and type of wind expected over that particular port, at what time and till what durations, and what could the possible impact on the infrastructure. Similarly is the case with respect to the boats and other infrastructure available with the fishermen. For railways, the railways which are under threat of tropical cyclones, they are registered as registered users, and they have the specific requirement. Certain tract of the railway lines, there could be the inundation if rainfall expected exceeds 50 millimeter. In certain areas, it could be 75 millimeter. And accordingly, those areas are given the specific warning and expected impacts. Same is the case with respect to the national highways. Another success story is with respect to the power sector. The power sector is provided information is a joint collaborative mechanism with the Power Supply and Distribution Corporation in India and India Military Department. There is a well-designed website for use by all the state-level distribution companies and also the generation companies, and which ensures the saving of the infrastructure during the approaching tropical cyclones. And similar approach we are following up with respect to other hazards that is on the way of development.
Great, thank you. Having got interest from the audience, we're going to move back to the panels because there's two more panelists to go through. They've been very patient. And we're going to move on to Dr. Vincent Gabaglio. The last two panelists are focusing more on the use of the data, I think. That's how I've interpreted their interest and their focus. So Dr. Gabaglio is working at the EU METSAT for the last 10 years in the division in charge of strategy, communication and international relations. His daily work focuses mainly on supporting users community outside of EU METSAT member states to get easier access to and make best use of that data, the products and services. So over to you, Vincent. Thanks for your patience. Thanks.
Yes, thank you. Thank you. Good morning, good afternoon, everyone. Thanks first for inviting EUMETSAT to participate to this very interesting panel. EUMETSAT indeed is the European organization in charge of monitoring weather and climate from space. So we are not users of the data, but we are mainly provider of data, and we'll try to explain how our data are improving early warning and disaster risk management. EUMETSAT operates about 10 satellites for weather, for climate, but also we do operate also satellites of the European Union Copernicus program that monitor actually the state of the atmosphere composition, and the marine and ocean also, which provide also informations on the state of the ocean. So if you could show my slides that I have prepared, that would be very useful. Yeah, thank you. We can go to the next slides. And this will actually gives a bit an echo to the first speaker, Mr. Cyclones in India. This is just to illustrate how satellite data improve weather forecasting. So here you have two scenarios of weather forecast. The upper one is taking into account satellite data, and the lower one is ignoring the satellite data, which means, by example, that was the case of the Irma cyclones in the Atlantic Oceans. With satellite data, we are able to forecast much more precisely and accurately some phenomena like the cyclones. And I would say over the last, we say in the meteorological world that we gain about 1 day forecast accuracy per decade. And this is mainly thanks to satellite data, but also the improvement of computer models and the improvement also of the scientific models. So this is just to illustrate that today satellites contribute very heavily to the weather forecast, to the accuracy of weather forecast, and is one of the tools that provides key informations. With satellite, we also forecast, first we see what is happening exactly when there is extreme weather events. So it's very much used for nowcasting. It improves weather forecasting from 1 to several days, but it's also a key tool for what we call seasonal forecasting. So thanks to satellite, we also can provide information to people who are more trying to look at how the next seasons will look like. Will it be more dry, more wet? Is it more rain expected, etc.? Next slide, please. So at EUMETSAT, we are obviously not the only one on this planet operating satellites for weather forecasts, and we, under the WMO umbrella, we are the secretariat of a group that coordinates agencies operating weather satellites. NOAA in the US, ISRO in India, China Meteorological Administration in India, and Japan also are all countries or regions operating weather satellites. There is strong coordinations to ensure a global coverage with different type of satellites on geostationary orbit and on what we call low Earth orbit, where we synchronize the orbit, we cross-calibrate the instrument in order to provide to our users a quantity, actually a huge quantity of satellite data that feeds models or inform different institutions at national level about what is going on when there is a severe weather event. Next slide. Several speakers spoke already about this early warning for all. I would just like to highlight the role of satellites. Mainly what I present on the two first slides is mainly a contribution to weather forecast. This is one of the main elements, let's say, is one of the elements of this cycles for disaster risk reduction. So satellites plays a key role in observing, modeling, and forecasting, which are the key input to early warning, and I will come back on that. We have also different type of satellites. By example, when the disaster occurs, there is, I give an example of the International Charter on Space for Major Disaster. So when a country is affected by a disaster, it can ask for all kinds of satellite data, including commercial data, which are actually provided free of charge in case of disaster to better try to map the extent of a disaster and inform the rescue team or different people involved in the post-disaster management. There is also contribution of satellites for increasing knowledge about disaster knowledge about also if we look at the archive of satellite data, we can better understand how when it's weather or climate-led disaster, what were the factors that led to this disaster. So really space and Earth observation in particular contribute to several aspects of this multi-hazard early warning system. What I would like to underline is that satellites and weather forecasts are only one element. What is very important is what was mentioned already is impact-based forecast or disaster early warning, risk-based warning. And those two elements actually, what it needs is a strong cooperation between the people operating the satellite, operating, I would say, the services, the forecast based on satellite, and the people managing, by example, in your case, infrastructure. In order to provide impact-based forecast, we need to mix various types of information, weather forecast, but also vulnerability and exposure. And it's only through co-design, or what Ben was mentioning, starting with the news of the needs of the communities, that services and early warning can be co-designed and have an impact to transform early warning into early actions. In order to conclude this short presentations, I just would like to mention one aspect. At EUMETSAT, we run together with the UK Met Office and several Met services in Europe a cost-benefit analysis to show the contribution actually of weather forecasts to the protections of property and infrastructure. And this is a figures that we got conservative figures that we got for Europe. Actually, it's 5.4 billion euro per year, which is saved in terms of protection of property and infrastructure due to weather forecasting. And this is figures. I mean, I could make available the full report that came up with these figures, but this is also an element that demonstrates that satellites might be expensive infrastructure to be put in place, but it contributes largely to the improvement of early warning. And thanks to co-design of services between infrastructure manager and weather forecasters to improve and to support the protection of property and infrastructure. Thank you. With this, I conclude my presentation and give you back the floor for any question if there are some.
Thank you, Vincent. I'm looking at the clock, and I do want to give Marie, who's been very patient, your chance to come in. The last of our panelists, Marie is with CEREMA in France, a technical reference on transport infrastructure and resilience and adaptation to climate change. And you are developing innovative methodologies and links with the World Road Association, PIARC, Technical Committee on Climate Change and Road Network Resilience. So please make the links with asset managers and how we use all that satellite data and other data available to help you do what you're doing. Hope I've got that right.
Dear participants, dear panelists, I'm very pleased to be here and to speak at this session. I will first present CEREMA, then I will speak about our activities in the field of resilience and more precisely transport resilience, and I will explain you how I make a link with the data challenges for more resilient infrastructures. CEREMA is a French major public agency for developing public expertise in the fields of urban planning, regional cohesion, and ecological and energy transition. And climate change is at the core of all our activities. We are a multidisciplinary scientific and technical resource and expertise center, and we provide assistance in assessing, implementing, developing public policies at both national and local levels. And we also are an integrator of skills with over 2,500 agents on 6 activity areas, including transport, infrastructures, environment, and risks. We our skills range from scientific activities to technical expertise. We work on resilience, and we have been working on resilience for over 10 years, because we can see that many transport managers are more and more aware of the worsening climate impacts on their infrastructures. And to help them face this challenge of climate change adaptation, we have been working for several years on the development of an approach to assess their vulnerability and then to identify and select the best adaptation, the more relevant adaptation solutions. So we published in 2019 a methodological guide entitled Vulnerabilities and Risks, Transport Infrastructures in the Face of Climate. Next slide, please. This methodology is based on 3 main steps. The first step is about defining the objectives, very precise objectives of the transport manager. For example, he may conduct a vulnerability assessment because he wants to assess the vulnerabilities of its road infrastructures, or he may more focus on some kind of risks. For example, assess the risks incurred on road infrastructures by flooding, for example. Then, including in this first step, we have the definition of the scopes of infrastructure, geographical scope, of course, scope of the services provided by the infrastructures, and climate or more generally hazard scope. And then we have to define also the horizon that will be used in order to assess these vulnerability levels. Then we have a second step that will be used to collect the data that will be used for the vulnerability assessment, then analyze the climate historical data and climate projection, and then analyze the infrastructure sensitivity. And the final step is more focused on the identification of adaptation solution, and then we have to prioritize these adaptation solutions in order to define a strategy. So we assisted the many public and private managers of roads, rails, and in ports sometimes in implementing this approach. For example, we have assisted SNCF, which is our national main rail operator. It has implemented many vulnerability assessments, and I will try to make a link with DataGap. So as you can see, this methodological guide takes into account a lot of things. Why? Because for its resilience approach is a systemic approach. So we take into account both infrastructure, but also network and the functionalities or services that are provided by the transport infrastructures. We take into account into our methodology both major events, such as flood events, but also slower evolutions, such as the global rise in temperatures linked with into account major impacts following a flood, for example, but also less visible impacts, such as chronic degradations on infrastructures. And we also try to take into account all the changes, such as changes in evolution, usage of the infrastructure, societal changes, etc. Therefore, we need a lot of data. We need data on infrastructures at the scale of a single infrastructure, but also at the scale of the whole network. We need data on the services provided by the infrastructures. This means we need the localization of infrastructures, but also their condition, their level of maintenance, the materials of construction, and we can also use data such as traffic, for example, economic services such as freight transport or tourism that are reflected by traffic data. We also need data on climate, past disasters, as well as future climate projections. And therefore, we need feedback on disaster. They are usually provided by the transport manager. And we need also a lot of other data in this methodology. It's very difficult to collect and to gather and use all this data for many reasons. For example, and maybe the major reason or the major challenge we have to face with is that we lack some data. More especially, we lack data on our assets. When we helped SNCF, our national main rail operator, in implementing this vulnerability assessment, for example, we had to challenge we had to challenge their data, and we had a lack of data. For example, we didn't know where were some culverts. And the localization of the culverts is very important, because if you have a big event, very heavy precipitations, for example, and a big flood event, if the culvert is very small or too small, you can have a big disaster then. We also have problems because we miss some data on climate, some climate data, for example, floodings or water runoff. We are currently developing a methodology to assess water runoff, but therefore we need data on soils, on for example, precipitation patterns, etc. So we move from one data challenge to another data challenge. We also have a big lack of knowledge on the impacts of climate events on the infrastructures. Maybe you will think, well, we all know the impacts of floods on rail networks, for example, but it's very difficult to characterize these impacts. For example, for which level of flood do we have big disaster on the rail structure, or on the or if we take a road, if we have a very big flood event, do the road will be only closed, or do we will have a bigger problem with the destruction of the infrastructures? We are not able to characterize this very well. For example, for the
You can hear me in the room.
Yeah.
Oh, sorry. I do apologize. I'm getting a message that I need to wrap the session up. So, one last sentence from you? I'm sorry that we've run over to everybody in the audience as well.
Okay, I will just end my presentation by saying that we also have lack on of knowledge on costs, and therefore it's very difficult to identify the most relevant adaptation solutions.
Okay, thank you. Thank you to all the panelists. Sorry, Marie, for closing you off. I know you did join us at quite short notice over the last couple of weeks, so thanks for all your effort. Thanks for the questions. Thanks for the flow. Thanks for the question from the floor. I know there are lots more. Just feed them in and we'll deal with them. Thank you to everybody. Thank you for Dr. Mark Patter for the start, for the keynote speech. Thank you. And one last.
See you, everyone. Nice to see you.
Thanks you everyone.